Okay, for algebra notes, we are doing 4.6, which is formalizing relations and functions. So let's get some of the key vocabulary down first. A relation is a pairing of numbers in one set. Okay, and this, you could either just watch this or you can write this part down too if you want, but it is going to often be represented as ordered pairs. And if you guys happen to have forgotten what ordered pairs are, it is like x comma y. Oops, can't even see that. There you go. So it's a relation is a pairing of numbers in one set, often represented as ordered pairs like x comma y. Okay, and then the domain would be in this ordered pairs, it would be the x values. So the domain always represents your x values, and then the range represents your y values. So we'll do some of those down here in our lesson today. So number 1 starts in and says, identify the domain and the range. So again, the domain is the x values. So this is x, y, x, y, x, y, x, y. So all the x values would be the domain. So -2, 0, 4, 5. That's the domain because that's just the x values. And then the range is 0.5, 2.5, 6.5, 2.5. So we're going to represent those first, and then we'll talk about a mapping diagram in just a second. So let's go ahead and write down the domain. D for me is going to represent the domain. That would be -2, 0, 4, and 5. The range we already talked about was 0.5, 2.5, 6.5, and 2.5. Okay, let's talk about this idea of representing the domain and the range with a mapping diagram. So a mapping diagram looks like bubbles. So it looks like 2 bubbles, and we're going to draw arrows from the domain to the range. So the domain is always going to be, the x values is going to be in the first bubble. So that's -2, 0, 4, and 5. The range is 0.5, 2.5, 6.5, and actually I don't need to write 2.5 again because it's already here. So then what we're going to do in order to make it a mapping diagram is we're going to draw arrows from each input to its output. So from -2 to 0.5. So -2's input, the domain is also the input, and the range is also the output. Okay, then the next one is 0, 2.5. So from 0, the input goes to 2.5, which is the output. The next one, 4 and 6.5. 4 is the input, 6.5 is the output. And then the last one, 5, 2.5. 5 is the input, 2.5 is the output. So the question is asking is the relation a function? So let me go over with you what it means to be a function. Each individual input has to be paired with its own output. So I know you might say this is a no because 0 goes to 2.5 and 5 goes to 2.5, but actually that's okay because the inputs are each different. So each input has to be going to a separate output. So each of these, there's only one line. If I were to cover up the outputs, each of these has its own line coming from it. Okay, so if -2 was drawn to something and -2 was drawn to something else, that would make it not a function. But because each input has its own line coming from it, has its own output, then this one is a yes. This is a function. All right, let's try this one. So first we're going to list the domain. That's the x values. So that is 6, 4, 6. I can already tell something about this, and 5. The range is 5, 3, 4, and 8. So when we map our inputs and our outputs, they are going to be 6, 4, we don't need to write a 6 because it's already here, and 5. Over here we've got 5, 3, 4, and 8. And let's match them up. 6, 5, 4, 3, 6, 4, and 5, 8. Okay, if we were to look, does each input only have one output? 5 only has one output, 4 only has one output, but 6 has 2 outputs. So that is why this is not a function. Okay, they can go, again, it's hard to kind of keep this straight. They could both have the same output, but each input has to be different. Each input can only be paired with one output. This input is paired with 2 different outputs. So that is why it is no. Really, all you need to do is look at the x values, the domain. The domain, or the inputs, is really the thing that decides. So if this one is 2, then it's no. So we already could have noticed that way up here. All right, some key vocabulary is a vertical line test. So what this is if any vertical line passes through more than one point of the graph. I didn't give you guys very much space. I'm sorry about this. It is not a function. Okay, and I'll show you what that appears to be. So this one that was no, this would have failed the vertical line test. So we could have noticed that this was not going to be a function because there were 2 6s on the input, or the input had 2 different outputs, or it would have failed this vertical line test, which we will talk about in a minute. And then function notation is actually described down here, so we'll talk about that in a minute too. All right, let's talk about a vertical line test. Let's go ahead and graph these points on this graph. So -4, 2, -3, 1, 0, -2, -4, -1. We could really just stop right there and see that it's not a function, but I'm gonna keep going. It fails the vertical line test. We'll talk about that in a second. And then 1, 2. So 1, 2. Okay, it can be a function if, vertically speaking, there's nothing except one line, one dot that hits it. So that one's okay vertically. This one's okay vertically. See how it only hits once? This is fine, this is fine, this is fine. However, when you get here and vertically it hits 2 different spots at the same time, it fails the vertical line test. So this is what makes it not a function. You cannot have a vertical line above and below. And we could have noticed that if we had just been looking at the inputs or just the domain. Because remember, just like up here, you can't have the domain twice or it's not a function. So we could have noticed that here, but this is what it looks like on the graph. That makes it have a line above and below vertically. I don't know if you guys remember with the turtle crossing, but if we had a vertical line with the turtle crossing, the turtle disappeared because it's impossible to be in 2 places at once. So this is why it fails the vertical line test and it makes it not a function. All right. This was a review of yesterday's lesson. If we can't graph anything unless there are some ordered pairs to plot. And if there are no ordered pairs, like there aren't here, we're going to have to make them. So we have to choose some x and y values, and just be careful because the x's you plug in are going to be squared first, and then we're going to add that negative thing to it. So I'm going to just choose -2, -1, 0, 1, and 2. Those are usually pretty good choices, pretty solid choices. So -2 squared is +4, and then this little negative attaches itself back to it. So -4 plus 3 is -1. -1 squared, -1 times -1 is +1. but then this little negative outside here is going to attach itself back to it. So negative 1 plus 3 is 2. 0 would make the whole thing 0. Plus 3. 1 squared is 1. The negative is going to attach itself to it, so negative 1 plus 3 is 2. And then 2 squared is 4, and then the negative attaches itself to it, so negative 4 plus 3 is negative 1. And what you might notice is that we do have some repeated range values, y values, output, but again, that's okay. You can have numbers that are drawn to the same output. They just each have to have their own line, each have to be different on the input. So let's graph this, and I do believe this is going to be a function, even though some of these repeat. So negative 2, negative 1, negative 1, 2, 0, 3, 1, 2, and 2, negative 1. Okay, I know that this is a weird function. You guys actually will do these later this year. It's called a parabola, but you don't need to know that right now. What you need to know is, does it pass the vertical line test? So this is still a function, it's okay. This is still a function. This is okay, it hits once. 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 So we pass. So this is a yes. This is definitely a function. All right. Up here in the key vocabulary, function notation, this is actually the only thing function notation is. This is how the equation has been written in the past, y equals negative 3x plus 1. If we're using function notation, literally the only thing that changes is y becomes the f of x. F of x equals negative 3x plus 1, and I promise you that these just mean the same thing. So it's really kind of pointless to have function notation besides the fact that it tells you it's going to be a function. You won't have to guess if it's a function. It will be, because it's telling you it's a function, the function of x. So the f of x is the same thing as y. Yeah, I already read it, the f of x. So down here they've got a function notation, but really that just means y equals. So here's the function, y equals, or the f of x equals negative 1.5x plus 4. If this is the domain, what is the range? So what they're saying is, here's my x values, here's my y. The x values, which is the domain, are 1, 2, 3, and 4. What is the range? So what are my y values? Well, this is just a simple calculator problem, because we're going to take each of these x's and we're going to plug it in for x and solve it and see what our y values are. So here we go. Let's start in. 1 times negative 1.5 is negative 1.5 plus 4. Negative 1.5 plus 4 is 2.5. All right, let's try 2. 2 times negative 1.5 plus 4. 1. Now we got 3 times negative 1.5 plus 4. Negative 0.5. And then lastly, 4 times negative 1.5 plus 4 is negative 2. So this is our range. The domain was 1, 2, 3, 4. The range is 2.5, 1, negative 0.5, and negative 2. Which of those? Well, it's not this, because that only gives us 3. This is negative 2.5, so that's not it. Negative 2.5 again. So negative 2, negative 0.5, 1, and 2.5. So it is A. Okay, on the back, it's a you try. I would like for you guys to pause the video now and do some of these you try, and then push play again and see how you did. Okay, is it a function? I would just be looking at the domain. Negative 2, -1, 0, and 1. All the domains are different. Therefore, yes, this is a function. Number 2, give it a vertical line test. Everywhere you go vertically, our graph only hits it in exactly one spot. So this is also a function. When it says what is the function of 2, that means plug 2 in for x and solve it. So it's saying if the domain was 2, what would it be? So it would just be 4 times 2, which is 8, plus 1, which is 9. It says this is the domain, what is the range? So here we go again. This is the domain, -4, -2, 0, 2, and 4. Therefore, what is the range? So -4 times half is -2. -2 times half is -1. 0 times half is 0. 2 times half is 1. 4 times half is 2. So our range is -2, -1, 0, 1, and 2. Last section, use the vertical line test, determine whether the relation is a function, yes or no. I can see right away this one is no, it fails the vertical line test. This one is also no, it fails the vertical line test a lot of times in between too. So this one is also no. This one though, I think everywhere you draw a line vertically, it will just be hitting the graph in one exact spot. So this one actually is a yes.